All right, so taking a look here at number 23, we have the directions graph the compound inequality. And again, we're given two inequalities, one being x plus y is greater than or equal to 2, and y is less than or equal to 2. So we know that when we're given two inequalities like this, we're going to graph each of them like we would normally. We're going to shade just like we would normally. And then at the very end, if we are dealing with a problem that has an and in between, whatever the double shaded portion of our graph is, we're going to go back and emphasize by really shading in that double portion and indicating that we're only interested in the portion of the graph that is double shaded. But we're getting a little ahead of ourselves. Let's go ahead and just go and graph each of these inequalities and put them on our grid just like we would normally. All right, so we know by now that with inequalities, we're not going to let this inequality scare us, right? We're going to pretend that it is just an equal sign for the purposes of graphing. And if we were given x plus y equals 2, we know how to graph that. We can either choose points, we can go ahead and solve for the x and y intercepts, or we can set this to y equals mx plus b, and I think we'll go ahead and do that here. So we'll subtract x from both sides, and that's going to leave us with y equals negative x plus 2. All right, and in this form, this is a nice form because we're easily able to identify our y-intercept, which in this case is positive 2. So we'll go up to positive 2 on our y-axis. And from our y-intercept, that first point, we're going to use the slope of our equation, the slope of our line, to find the next point. And in this case, our slope is negative 1. And so starting at 2 on the y-axis, if our slope is negative 1, we're going to go down 1 unit and over 1. Down 1, over 1, down 1, over 1. And we can do this an infinite number of times, right? But we really don't have to. We only need 2 points in order to graph a line. And before we actually graph the line itself, let's go back to the inequality and see whether or not we're dealing with a solid or a dotted line. And we can see that because our inequality is greater than or equal to, we're going to be using a solid line. So let's see if I can draw a solid line freehand. All right, not too bad. It'll do. All right, and we know that with inequalities, we are going to be shading. So we're either shading below this line or above this line. And a good test point to use is going to be 0, 0, right? Because we have to use a test point, and that test point tells us which side of the line we're shading on. And if your line does not go through 0, 0, 0, 0 is a nice point to use because it usually makes the math a little easier. All right, but you can choose any point you want so long as the point you're choosing to test does not fall on the line. All right, so we're going to choose 0, 0, so our test point, 0, 0, and again, right here, our origin. And you're going to take this test point, plug it into the original inequality, and see whether or not you get a true statement. So in this case, we're going to take our 0, 0, so plugging in 0 for x, plus plugging 0 in for y, is greater than or equal to 2. Well, 0 plus 0 is just 0, is greater than or equal to 2. And so, is this a true statement? Is 0 greater than or equal to 2? Well, no, of course not. That's a false statement. And since this point that we chose to test was below the line and we got a false answer, a false statement, that means any point below this line will also give us a false statement. And we only shade where the answers make our inequality true, where the points make our inequality true. So if the answers below the line make our inequality false, well then the points above the inequality are going to make our inequality true. All right, so we've got the first inequality down. Let's go ahead and deal with our second inequality. So we have y is less than or equal to 2, but again, we're going to pretend that inequality is an equal sign, and so we have y equals 2, and we know how to graph this, don't we? This is simply a horizontal line, and we know that because we have the y, right? When it's just a singular variable, whatever variable you're given is the axis that your line is going to be going through. And where does it go through that axis? Well, it goes through the axis at whatever it is set equal to. And in this case, it's set equal to positive 2. So let's go to positive 2 on that y-axis. And what kind of line are we drawing? Solid or dotted? Well, we've got to go back to this inequality, and we see that its y is less than or equal to 2, and so we know that's going to be a solid line, something like that. All right, and now that we've graphed that line, we can go ahead and get rid of the equal sign and go back to our inequality, because now this inequality is going to help us determine whether we're shading above the green line or below the green line. And the inequality is saying that y is less than or equal to 2. Well, where are all of the y values that are less than or equal to 2? Are they above the green line or are they below the green line? Well, above we have 3, 4, 5, 6, 7. So those aren't less than 2, but below the green line we have 1, 0, -1, -2, and so on. So if we're looking for all of the y values less than 2, well, they fall below the line, and so that means we want to shade below the line. All right. So now that we've shaded and graphed both of our inequalities, we want to return to the word separating our inequalities. And in this case, we have and. And you'll recall from the previous examples, when you have and separating your inequalities, your answer is only the double shaded region of the graph. All right, and what does double shaded mean? Well, it means, let's take a look at our graph here, and here I can see that I only have blue, right? Down here I only have green. I don't have anything here, but right here, this little triangle here, I have both blue and green, and that's what we consider the double shaded region. So go back to your graph and you want to reshade and really make that double shaded portion darker than the rest of the graph so that your professor knows that you are only interested in this region of the graph. And what this is saying is that the points that fall within the red shaded region, that double shaded region, are the points that if you were to choose them and test them, those points would satisfy or make both of your inequalities true at the same time. If you were to choose a point from just the green shaded region, you would only find points that satisfy or make the y is less than or equal to 2 true. If you were to choose points from just the blue, you would find points that only make the x plus y is greater than or equal to 2 true. But all of the points found in the red make both of these inequalities true at the same time. And that's what we're looking for when the word is and. We want this double shaded region. All right, so just really emphasize this region of your graph and you are good to go.